mic works. The mic works. And check this out. 6, 11, 4, 4, 12. Let me just turn on the highlighting. Sorry about that. Anyway, in the bottom right corner, you should see the number 38 colon 54 colon 34. That means 38 hours, 54 minutes, and 34 seconds. That's how much video we have recorded in the past 5 sessions. I mean, in the past 5 videos that are going to be published on YouTube. This will actually take like entire day to even render, so I'm going to leave it overnight, and then it will be uploaded to YouTube. I've been doing audio processing for the whole day, and I'm glad that this is over with. It's actually easier for me to just get a lot of music from the internet and just put it all in. It also took me pretty much the entire day yesterday to put the subtitles. And I'm really happy that this is finally over, because we can move on to the next thing. And what is the next thing, you might be wondering? Well, this is the Leduc function. This is the play loop. This is the event loop. We did this before. And we also have the game model. So what we should do is combine these two together and maybe finally play against a random player. I mean, I was saying that we could also implement the game in the test itself. Here you have the test tree, but it's it's passing pretty much constant data through the neural network model. We could start work on a test for which uses the actual game, but I thought, yeah, I mean, it wouldn't be too difficult to do this. But what I finally want to do is maybe play against the actual player which is executed on the GPU. It's also the case that the play module comes before the tests, so yeah, why don't we finally take care of this? It will be great to finally get it out of the way. And in addition to that, what we have to do is integrate the play and the training sections into a single backend namespace. Otherwise, we won't be able to share the trained models with the game itself. Yeah, we'll after we implement the random neural player, the random AI player, we'll start work on that. So yeah, it's final time to get a little bit serious. We've been the past 3 sessions that are going to be covered in the past 5 videos. I mean, the sessions of the past 3 weeks that are going to be covered in the past 5 videos are kind of a blur to me, because we've been doing a bunch of refactoring. We also implemented higher ranked types, and we've fixed a bunch of errors. But in terms of the actual stickiness, nothing really stands out to me from what we've been doing, like some kind of major accomplishment. Instead, it feels like we've been working through the tech debt, so to speak. And we really didn't need to do that, because if you go over the videos, you'll see that we've figured out a bunch of errors in the kernels themselves. If we had tried using the kernels that we had before to run the actual agents, to run the trained agents, it wouldn't have worked. So taking the time to do the masked softmax was very good, because it revealed a bunch of errors that we wouldn't have figured out otherwise. We also figured out that the cooperative group reduce and scan functions pass the arguments in arbitrary order. So the reduction function needs to be made in such a way that it doesn't expect, for example, if we have the first and the second argument A and B, it must be the reduction function must be made so it doesn't expect that a will be to the left of b in terms of its address. That was very important. And by address I mean the address in the array being mapped over. Not checking for that earlier led to a bunch of errors. Another error that we also fixed in the primitives module, also in the script sampling, is this script sampling is this thing. It turns out this probability that was being generated, previously the probability was just random uniform RNG, and every thread would generate the probability like this. But the problem is that this probability would end up being different in every thread, while instead it needs to be shared. Otherwise, yeah, we'd also get an error. And that's something that we fixed. That's why this is a lot more complex. And also we don't really have a good way of actually sharing the probability, so we do a map and then a reduce to actually share it. If any of you want to do something like a local share function, that would be great. But otherwise, we'll be going with this for now. It's good enough that we optimize the global memory accesses. Now it's all fused properly, and the fact that we're doing a bunch of extra reductions here and in shared memory, it's simply too bad. But I don't have time to fix it. I mean, I do, but I don't have the will to fix it now. I want to work on other things. It would be a good exercise for you if you can make local shared and contribute it to the library. So yeah, it's pretty great. Yesterday and today, I pretty much it doesn't feel good that I spent my entire day doing audio processing and putting in subtitles. I think I'm going to change my workflow a little, and so I don't have to spend a lot of time in the future setting up I mean, not the subtitles, but the video timestamps. So that I'll be going back to my old routine of putting them in as I go along. I simply didn't want to be interrupted, but that has a cost. Oh yeah, it really does feel good to have this out of the way. We did a lot of good work in this whole module, and yeah, now I think it's production ready. We can use this to do serious things. We'll get back to this train module later and do the test for after that. For now, our goal will be to just go into the Leduc function, go into play, and all of this is commented out right now. We'll comment it in and move from there. We'll try to figure out how to get the neural network model to run in the game itself. That will be an accomplishment. I mean, it might not seem like much to just simply get a random player to play the game, a random neural player to play the game, but it's not that. It's a single step to go from a random player to a trained player, but we have to make dozens of steps to get just to the random player. I'm really happy about this. It was a lot of work to even just make the games themselves. It's amazing that we've come this far. And I don't know whether I'll get an actual real-world benefit from doing all of this, but this is the path that I've chosen for myself. I've been programming since 2015, and I haven't really accomplished anything in particular. I've really been pursuing the Singularity, And that's really a distinct thing from trying to make artificial general intelligence, because my goal is not actually that, but to get access to the self-improvement loop. And it will, there will be more to say about that in the future. Maybe I'll do a video about the secrets of the singularity that they aren't telling you. But to get to the self-improvement loop, we have to first make artificial general intelligence. And even before that, my goals are actually not that, but they're much lower. Like, I'd very much like if not just getting artificial general intelligence, but say simple working poker playing agents. I want to be able to train them stably, and I want to master the process of creating such agents. It's a very simple task, but even though I've been programming since 2015, I couldn't do it. And you might be wondering why exactly. Well, okay, of course, I haven't been working on poker playing agents all this time. Like in 2015 and 16, I've been working on a machine learning library in F#. Back then, I really believed in deep learning, so I thought that upgrading my skills and getting good at functional programming would help me grow as a programmer and get me closer to my ultimate goals. Then I started working on the Spiral language because F# wasn't good enough to make a GPU-focused machine learning library. That resulted in the old Spiral language that you can still see. Let's see. Spiral. There are a bunch of branches over here. Some of them are various machine learning experiments that I did. And in particular, this branch is from 2018. And this is where you can find the old Spiral language. It's similar to the current Spiral language, but it didn't. For example, it didn't have editor support. So all this code that you see, for example, here, these are F# strings. It was very tedious to program like that, as you can imagine, and it was all in the bottom-up style. I did a machine learning library in that, and I got very tired by the end of 2018. I'd make an experiment, and then I ping-pong from type error to type error. It was fucking insane. And I wasn't really making progress in deepening my understanding of machine learning. In 2019, I did a bunch of things after giving up for the first time. Amongst them, that was when I studied dependently typed programming. And that's what inspired some of the latest additions to the Spiral language, like higher rank types and GADTs. That's where I learned all of this. I mean, all of that, what those features were. And it was actually pretty fun to go through the Software Foundations book and do some programming in Idris and Agda and Cook. But it didn't get me better. Even though I learned formal theorem proving at that time, it didn't get me better at machine learning. I mean, and that's a kind of a pattern you'll see. If you could get snapshots of my life for the past 9 years, you'll see that pattern. I'd pursue machine learning, but I would just get better at programming. I'd work on machine learning libraries, I get better at programming, I learn functional programming, I even make an entire language, all for the sake of getting better at machine learning. But somehow, even though I have various other accomplishments, chiefly making the Spiral language, I never actually get better at machine fucking learning. And this is the huge deep learning machine learning wave, and it's amazing. It's like AI is developing by leaps and bounds. You have ChatGPT, you have stable diffusion, you have generative AI, you have all of these things, and somehow I'm failing in the midst of it all. I simply don't get the sense that I'm at all getting better at machine learning. Like, it doesn't take much skill to, take a neural net and put some data into it. But what does take skill is figuring out why these algorithms are wrong and then fixing them. Nobody in the world can do that currently, and what drives me absolutely insane is that even though I know exactly what is wrong with deep learning, I cannot fix it. I simply can't. And the solution for that is where we are currently. I understand what the problems are, I cannot fix them, I've finally accepted that. And I understand that trying to think better and work harder isn't going to do the trick either, because pretty much everybody in the world is trying to do that, but it's not working for them. And that brings us to the conclusion. It's not really that our brains are broken, it's that our processes are broken. We cannot get to the correct result with the incorrect process. We simply have to change the way that we are looking at machine learning entirely and adopt a different way of working. And this is very similar. Back in 2015, I think, I once did a compiler's course on a MOOC. I think it was on Coursera. And I did it in C++ back then. Back then I didn't know any functional programming. I only picked up F# after a month or two after the course was over for the first time. I think I did that course, I did a Scala course, and that got me hooked on functional programming. I thought the Scala was very interesting, but I ended up liking a language like F# much better, which it kind of felt more lightweight and so on. But I won't go too deeply into that. And what really stands out from that experience is that at one point I had some kind of weird concurrency bug, and I couldn't figure out what was wrong with the program. But while thinking about it, I realized that even though I didn't understand what was wrong with the program itself, I could redesign the program completely so that I could actually understand what was going on, and the design was such that the error couldn't possibly occur to begin with. And that was a key breakthrough. I think that was when I got better as a programmer. And we have to do the same for machine learning. The way things are going, we're probably going to have another AI winter. And Microsoft, Google, and everyone else, I mean, they won't be so lucky that they'll just stumble upon a breakthrough and then it will be a smooth road to AGI. To begin with, it's not really about AGI, it's about the self-improvement loop, and the self-improvement loop is iterative suicide. Anybody who enters the self-improvement loop has to be prepared for that. And once people understand on a subjective level what that really means, they're going to be a lot more reluctant to actually tap into that kind of power. What's happening right now in the world is pretty much very clownish. And I am feeling dejected, especially that I'm doing my best, but the world is not rewarding me. I've tossed the towel in twice, once in 2019, at the end of 2018, and once at the end of 2021, and now I'm at it again. At this time, I'm not going to have any expectations. Even though I said that we need to change the process, it's something that's easier said than done. So I'm just going to do this like in gaming. It's impossible to treat this as a job, and the expectancy of playing games is zero. And so I expect the value of this to my life to also be zero, but still, it's my obligation and my responsibility to pursue the singularity. So that is what I'm going to do. I'm not going to give up again. I'm going to see where this path leads to the very end, and if it leads to my destruction, then so be it. If those rich Silicon Valley people can just get to the singularity in the way that they find acceptable, then so be it. I'll accept that everything that I've imagined is simply a delusion. But right now it's not obvious whether it is a delusion or not, so I'm going to do what I can. I'll put in a few hours every day and enjoy the journey. Let's do some programming instead of just ranting about various things. But I do want you to understand why I'm doing this to begin with. Trying to make the pursuit of singularity is an arms race, but it's not a race to make AGI. It's a race to get to the self-improvement loop first. Okay, let's think about this. Model does not have the... I mean, where is it even supposed to find the model? ML layers, create model. Oh, yeah, I remember. Oh yeah, this is where we did the model. Okay, let's concern ourselves with this. What will assemble? I32. Oh, we are applying the block. Yeah. You remember that old error that we had? This is what started pretty much the entire refactoring run. I suddenly realized that the way we were applying blocks would lead to data races. So we changed all that. Softmax on discrete sample. Oh yeah, if we... Yeah, this should now be masked softmax, and I think this should be taken in a pair. I mean, should it? Graph tensor. Yeah. These are the sampling probabilities, and these are the indices. So this graph is okay. It's broken right now. Okay, we are going to. Okay, let's go into the train. Let's just copy paste this. Who cares? size red, size inner. Size thread. Yeah, it's fine if this is a pretty simple model for now. My motivation isn't very high. If you take a look at this commented out code here, that's pretty much, we already factored that out, all of that out into the game model. Let's see. Yeah, it's pretty much this. Sets the input person to 0, serializes the data into the input tensor. Yeah, that's pretty much this. Run the model on the inputs. Of course, this has a lot of other stuff that's very useful. So we definitely don't need any of this. Okay, so how are the game models created? Let's see. Model equals create model graph, paraminit model. Let's bring that here. Okay, PU history. Oh, not bad. Now we have the game model here. Yeah, I'm not really motivated, but on the other hand, it's what we're doing here is very straightforward. Okay, so we have the model right now. Leduc model, Leduc play. Okay, so the next in line is the play module. State to internal. Console, right element. Alright, open core ext. So, okay, that could be it, but it's not all, that's it. Okay, here we go. Now here we have the computer case. And this is supposed to be actual AI agent. Okay, how will we proceed? Okay, state private. ML layers model data. Oh, I see. This model data, I think that's we did. Okay, let's see. Model layers, model data. Let's see. Model. Yeah, these are the two parameters for the game model. And how are we going to deal with that? Let's see. What's the game model like? So here's the model itself. Oh yeah, and the model isn't necessarily a graph, but it does have the allocated arrays. Okay, let's see. How are we going to extract the model data from the game model? Let's think about that. We did this thing because we wanted a way to keep the model around. I mean, we should already be extracting it somewhere. So here we are getting the graph. The model is being created, and we have the ML layers model to model data. Oh, I see. And as for the game model, how are we creating it? Model, create model, and we're passing it a graph, then we are initializing it. And ML game model M, game model. That's how we're creating it. Like, what exactly are we going to do? We have the game model, do we want to extract? I mean, why not? Okay, how do we get rid of the existential? Okay, let's think about this. Let's make an utility function here. We'll name it extract model data. Let me just raise my table. I have this automatic standing desk, so you just need to press a button to lift it. And if you ever have problems with your hands, like I do, get this desk first of all. Yeah, I mean, it cost me like 200 euros, but it's worth it. It might be more beneficial to you than a new keyboard or a trackball mouse. I mean, if you haven't seen it, I have this Glow 80 keyboard, and yeah, it's pretty great. So you need to get a mouse pad for it, otherwise it will end up collecting dust on these silicone pads and sliding across the desk. Also, on my keyboard, the glue for the silicone pads is coming unloose, so that's also another issue. But otherwise, this key, I really do like the design of this keyboard. It's fantastic. I don't think I could ever go back to a regular keyboard. So let's see, model. Yeah, I need to extract it. Extract model data. Okay, game model data. And where do we find this? ML. Wait, yeah, it's in layers. So it's ML layers model data. What the hell? Oh, ML. What is the game model? It's ML game model M. ML game model M. Okay, and where is it? It takes in an input and an output. Okay. Cool. Maybe the model data should have an input and an output too, just simply for safety. Whatever. Let's add it. Oh no, wait. The model itself only has an output. So I guess. Okay, never mind the model data. Put in. Yeah, this can just remain as it is. Who cares? Let's first of all, what we'll do is get the model, and that equals exists t. Yeah, you know, it's been bothering me that we need to put in this. I mean, yeah, I've been thinking about doing this earlier, but let's work on the language for a little. I want to optimize this a little bit, because we can put in for alls at the start, but we cannot put in exists. So we're going to change that. Okay. Where is the block parsing? But what's the same on this? Now, where is this being used? Final references. Yeah, this is where the existential pattern is being actually parsed. And right now, in order to parse it, we need to put in parentheses. But if we didn't want to do that, we'd have to move it somewhere else, like yeah, I simply feel like doing this right now. But exists. It's not a root pattern, but pattern or. Oh great! Now this should be. We should be able to directly parse this in patterns. It will have a lot higher precedence than what it did before. I mean, compared to what it had before. Wait, why am I so sure that this is the correct thing? Like, no, it wouldn't fix the error necessarily. I think in root pattern war, that's where this is supposed to. Where are we even using this? Let's see. Because the pattern exists. Or do you want to simply overwrite this? How exactly do I want to handle it here? Okay, let's pause so I can think about this. Okay, so I will just do this. and s, and oh yeah, this is going to have to be changed. Maybe I'll make it but exists something else. Kn to go back. Kn. Root pattern type. All the other parsers are using this as well, so we might as well do that too. And we don't actually even need to have it here. I mean, if it's going to be parsable as a variable, if you're going to put it here, then it can also be just here like this. Yeah, like this. Yeah, Spiral does have a pretty complex parser, and what is really making it complex is the decision where annotations can be put and then not put. It actually took a lot of wrangling to get so we can write something like inal AB and then put a colon and then put in a type annotation. Without that, we could have made this a lot simpler, but never mind that. Okay, so this is just the pattern itself, and I also want to be able to parse the existential type. So this is another one of my design regrets. Okay, the parsers for the type itself are a bit simpler. We don't have, unlike with the patterns, we don't have a lot of functions outside the main one. So suppose we did this. I mean, suppose we put it here, and then functions. And now we have to deal with this allow wildcard equals false, but whatever. I guess we can try getting. I mean, we can try removing it. We already have checks everywhere to make sure that the exists pattern has. I mean, is usable inside. I mean, we already have checks everywhere to make sure that the type variable for the existential is being used inside its body. So it should be fine to not have to explicitly set the wildcard to false. Oh yeah, now we have moved this next to the for alls. This is just a small change to the language, but I think it will be a change for the better. Okay, finally compiled. Let's try running this. What's going on? I think we probably broke the parser, so... I see. I think, yeah, the exists is not optional anymore. That's what we got wrong. Okay, let me just go have lunch and then I'll finish this. Let's continue off where we left yesterday. What we have to do is make this exists optional. I added this like yesterday, but now it broke this part. So we have to fix it. Let's see. How about we do it like this? Okay, that's one thing. What about... okay, I'm a bit confused what's going on, what the types are here. Fun AB. So let's just write this. AB. Okay, so this is an option. Oh, okay, I see. I mean, it's not really a fold back, but it should be a regular fold, I think. And then let's see what's going on here. This is an option. This is a type expression. Option fold. You should be taking an option. For fuck's sake. Okay, let's. Now we are debugging a type error, but that's fine. It happens. Even I cannot get it right every time. Fail with. Let's see. It can. Oh, so this. Why is this trying to return a tuple? That's a bit. That's weird. Okay, so it takes in a folder, then it takes in a state, then it takes in an option. Oh yeah. So, and this is the option. So obviously the option has to go in last. But if we wanted to pass it in right away, we could just do this fallback. Oh yeah, now this works. Oh, it returns a type expression. Is this fine? Really? mean, didn't we have a type error due to this? Okay, I thought that this was a type error when we did it first, but I guess it's not. Okay, great. And now this option type is... Oh yeah. Let's not also forget to add the other part of the range. Plus range of expression B, I think. Or is it L? No, it should be, I think. Ah, it's a type expression. Great. Now the range of the entire exists statement is the actual entire statement instead of just the left side. Okay, great. And I think this should suffice to actually parse the exists statement. It should be possible, now that we have this, it should be possible to write for all t exists q without necessarily having to wrap the existential in a parenthesis. Of course, one consequence of this kind of parsing is that if we wanted to do something like this, then we'd actually need to put the for all in a parenthesis. I mean, that's just due to how the operator precedence works. Well, yeah, I don't think there's an easy way to actually allow the existentials and the for alls to be parsed arbitrarily. Like, we cannot... okay, here we're passing a for all, and then we're passing an existential, but we cannot just try and loop back to passing a for all if we fail to pass the existential. I mean, even if we succeed, we cannot loop back, because that would create a cycle, and the parser would crash, I think. This is good enough. I just wanted to do a tiny improvement, so we don't have to put the parentheses when parsing existentials everywhere. I mean, I'm a bit confused. I mean, did we really need the parentheses last time? Sorry, I mean, it's been a day since the previous session, and I remember clearly that existential should need parentheses, but even if the existential was here, why exactly would we need them? I forgot why that was the case. Okay, here we are in the base, and okay, let's do a type that has an existential type. QE equals exists t int, and really. So why the hell are we even doing this? Okay, yeah, here we need one, but yeah, we don't need it in the type. So why am I trying to move it? And in fact, it's actually just as I said here. Here we can only parse the for all and then an existential, and after that we need to put a parentheses. But If we actually had the for all being parsed here, as well as the existential, then it could be parsed in an arbitrary manner. So what I'm doing is actually completely the opposite of what I should be doing. Instead of moving the existential here next to the for all, I should be moving the for all next to the existential. Okay, this was weird. Okay, I guess let's commit it. Save. We're moving the existential in the wrong place. We should have moved Okay, so I guess we'll have to go to a previous commit, but why couldn't we also have the existential in a similar place like this in the pattern? Excuse me. And that's what I'm confused about right now. Okay, let's take a look at the history. View history. Fuck, it's showing me the history of everything. But we want is simply the history of this particular file. You know, I can... For some reason, this is a lot easier in Visual Studio than Visual Studio Code. Here I just go show me the fucking history and it shows it. But in Visual Studio Code it's kind of... I don't know, it's more complicated. Okay, so let's see. Block parsing, and this is line 1100. Okay, let's just do a search for this. Okay, and previously the existential was yeah, like this, and this was fine. Yeah, this comment misled me. We should be moving the for alls next to the existential instead of how it's done currently. But what about the pattern? In fact, okay, let's undo the what we've done here. Okay, here's the block parsing. No, what the hell did I even select? Okay, we have what we had before. Also, let's go into the pattern, root pattern, and yeah, here we have the pattern exists. I mean, and this doesn't really have anything to do with needing our parentheses around an existential. What determines whether the parentheses are needed in the initial pattern is whether the pattern is being parsed here in root pattern variable. Okay, so yeah, it's not very far from... We just need to scroll up a bit. And here we have the pattern exists. And here we have a serious error because we no longer have we're no longer passing the OR pattern. Instead, we had an we had pattern exists right here, right above path us, but we removed it. But we forgot to change this back to pattern or. So that's probably what broke the parser. Okay, and here we have the pattern exists, and that's very good. No need to change anything here, because I was afraid that we'd have path exists here. Okay, so what do we do here? Okay, here we have the for all, so we need to move them. Oops. In Visual Studio, you select a word with Ctrl V, but in Visual Studio Code, you do that with Ctrl D. And I press Ctrl D, and it instead duplicates the line. Okay, let me raise the table because my hand is starting to itch. Okay, so we have the functions. Yeah, this should be here, and we have to parse the for alls. So okay, range. We no longer need the pipe. And we'll just pass in root type. Yeah, we can just disallow the wildcards. And what? Then we pop it in here, and I guess we don't need the option fallback. But of course, we're still getting an error. And why is that? Why are we getting an error? We'll have to investigate what the types of this are. Fun AB. This is the range. The first argument here is a list, and this is yeah, this is the body. So yeah, what we can do is simply yeah, like this, and this is the same thing as I mean, it's the same thing as doing something like first LB, second LB. Yeah, it's like that exactly. We're just passing in the list and the body here, and yeah, that's it. I mean, whatever. We can also do it. LB. I mean, it's not really any more complicated. Now we have that. Yeah, I like this. I like this a lot. Oh, now the for alls are where they should be. Yeah. instead of moving the existentials next to the for alls, we move the for alls next to the existential. And do we really need to disallow the wildcard? I don't think that's the case. We can just let the user decide. Okay, now let's see whether the parser is still broken. Oh, I see. Now, because of this change, the annotation... the annotations have changed as well. What do we want to do? This is in... Is this in... I mean, it's weird that... No, this is not in root type. I guess it's in... is it in patvar? I guess it's in path exists. Where is the... Okay, let me pause here. I want to understand this a bit better. The reason why things are broken now is because we probably changed the precedence of how the types are being parsed in the existential pattern. But I don't understand where exactly we did that. So I guess I need to think about this for a bit. It's weird that this is happening. I didn't expect it. And or maybe I should have. Just a sec. I'm looking at this and I'm noticing that it says root pattern here. And I think I might have maybe changed that to root pattern type yesterday. And that is what could be causing the trouble. Let's see. Okay, where the hell is... Yeah. Yeah, now we have the root pattern type, and that is what's causing all of our issues. I'll go back to using root pattern, and the root pattern type, what it does is this root pattern type. You can see that it parses the usual thing, and then it also parses a type annotation. So if we do that, while parsing the existential, it might end up parsing it inside the existential body. That's a big problem. So, okay, but exists. Yeah, okay, let's do it. Let's go back to what we had. I mean, let's go not back to what we had, but let's publish it. No. Well, let's run this. Oh, great. What was the problem here? Oh yeah, I think this is supposed to be game model. And in particular, okay, so, oh yeah, we're not this is not a parsing error anymore. We're just not returning the correct type. Okay, let's just open this. Open. And yeah, but basically the language the language parser now works. We can write the existential like this without having to put the parentheses around it, and that's great. And we can also we should be able to mix and match for-rows and existentials freely. Okay, let's see, type QEA row T exists Y T and Y, and we can also do this. Yeah, previously this wouldn't have been possible. We'd have gotten an error when trying to parse the for all. In fact, let me prove that. We're going to run this with the previous version of Spiral. This is the one that's on the VS Code Marketplace, and really, it does work. Okay, what about this? Oh, I guess I was wrong. It does parse the existentials and the for alls as they should be. I guess the main difference is if you have. Okay, suppose I tried doing something like. Yeah, suppose we tried doing something like this. Now we get a parsing error, but with the new version, it should work. Yeah, it works, and it's complaining that it's simply complaining that the variables aren't being used in the type signature. Okay, this is great. Yeah, we can consider this an improvement to the parser. So, okay, let's make a commit. I don't need to change this. I mean, I don't need to test this too much because most likely everything will work much as before. Changed the way. Change the way. Minor press. Okay. Now let's release a new version of Spiral. I'm going to this script and then just PowerShell run. And it should be released on the VS Code Marketplace in a few minutes. Is it? This is 2.13.2, I think. Oh yeah. And it's 12 p.m. so we're going to stop here for a little bit so we can go have breakfast. After that we'll continue. This was not a bad morning session. We want to get back to doing to working on the game and the machine learning library too. Okay, the new Spiral is out. And we can resume what we were doing yesterday. We don't need this. Yesterday where we left off is making this extract model data function. And what we needed that for, I can't really recall at this moment, but it had something to do with yeah, we're going to have to put in the model for the game, and we're going to have a way of extracting the model data. So that's why we need it. Now, okay, let's do it. I think we had a function that's called model to model data, and then we just pass it the model. Yeah, and then we get this back out. Oh yeah, no problem. And we will create this function. Now we actually need to figure out where we want to use it, but never mind that for now. We have the game model. This thing is fine. Oh yeah, the game model. We have to put it in the initialize function. That's what I think. Okay, let's take a look at. Okay, we don't need this. Let's close. Let's also close that. We have the play, and this takes in the model graph, creates the model, and then turns the model to model data. One issue is that this doesn't actually initialize it. And that's in Leduc model. Oh, really? No, I mean, this shouldn't be here. It should be in something like game model M. And let's see. This is in ML. Okay, I see. So we only need layers. Okay, I apologize for the vibrations that are going on. I guess there's some kind of drilling going on outside, like in the distance, and it's making this. It's making my ceiling light rumble. Okay, now it's gone away. Okay, so we have the game model for the Leduc game. We have the model extraction function if you're going to play. We need extract. Okay. ML game model M. Oh no, not bad. Yeah, this is good enough for initialize, but yeah, I was saying this is good enough for initialize, but one problem is that running this function will just will reinitialize the model every time. And how can we create this game model from a model data? Okay, that's one issue that we have to take care of. We now have to create a completely new game model, but what when we get it back again? How will we create it then? And if you look at game model M, I think we have something to. Okay, we have something to extract it. Okay, we have the run function. That's fine. But yeah, I mean, didn't we have a test that takes in the game model? I mean, the model data and then reuses it. Okay, so the model data is okay. We have the model to model data and model data to model. Okay. So okay, let's make this to model data, and we also want a function that's called from model data, and it will be the inverse of the above function. So okay, now what we'll do is use model data to model. We'll pass the x in. Okay, let me just think about this. I takes in the graph as the first argument. Okay. So we need a graph. Graph B. Okay, we have the model B. Yeah, and I guess we also need the input and the output functions. Input int okay, so where are we getting this error? Oh yeah, this is supposed to be a type. And graph input output. Okay, so and the graph is supposed to have an existential. Exists t. And yeah, this is kind of complicated. We might have to rethink how we are doing the Leduc model. I mean, we have the graph. It's easy to get the model from that. And yeah, we need to extract the existential from the graph. Existing graph. Not bad. And we finally have the model. And we'll return the game model input output. And I guess this will be the yeah this is the exact type, but I guess it's complaining that it doesn't have the proper type at this exists. Yeah, basically by the time when it first enters the body, it doesn't actually know what the type of the model is, so that's why it needs this. I mean, that's why it needs the type annotation. Oh, not bad. Okay, model. I mean, do we need all of this? Okay, how about we do this? We'll name this input. This is, and why is it giving us trouble? Oh yeah, because it's overwriting things here. Okay, so what we might want to do is instead of returning a game model here, it might be better to just okay, let's do the enol output. For a second, I really want this to be input graph and output, and that would make things clear. But it would be overwriting this the layer name. Ugh. Maybe something like this. Okay. Let's just pause for a bit. I have no idea what I'm even thinking about. Let's make this model input. I also just put in the model output. Oops. Okay, and this one is pretty simple. Oh yeah, I guess let's give it a type annotation. A colon int. No, wait, it's actually pretty weird that it doesn't know that this is a function. I mean, maybe this is another parser thing that we could fix. You kind of you just do tiny things like this, and that's how that's how the language gets better. I mean, it's not improving a language is not all about putting in a major feature like JDTs or high-ranked types. It's often in little things like this that make a difference. So row for all or row fun. So is this the only place? Yeah. Oh yeah, it's kind of... Okay, how exactly do we want to deal with this? Right now it's very simple. But I guess if you wanted to change this, we'd need to maybe extract this into a variable and then iterate over it. Okay, here's what we're going to do. Patvar, our name. Let rec loop. And then what? We have the loop. Equal function. We'll paste this, and this is rec. If is rec, then we just do. Then we just paste this in. Else. Let's do the other case. And then we call the loop with the body. Oh yeah, not bad at all. Oh, wait. We got the cases the wrong way around. If it's recursive, then yeah, like this. And then you also have to take care of the raw annotation. Yeah, great. We have to take care of this case, and this is the range, the body, and the type. Okay, range, body, type, and then we just do loop body. Now, if there is an annotation on the node, it will just look inside the annotation, even if it's at the top level. And yeah, I think this should give us the behavior that we want, but it won't really hurt the language in any way. Let's give this a try. In my opinion, the main thing that the language is currently missing aren't type system features or anything like that. What they're missing is editor features like renaming and autocomplete. The autocomplete that currently exists in Spiral isn't actually anything implemented on my own side, but it's something provided by the VS Code editor. I guess it's looking into the variables, into the tokens that are being used in the text and suggesting them. And that actually ends up giving us pretty good results, but they could be better with the proper autocomplete. And I really am missing renaming, even though compared to something like F# or C#, renaming would be a lot more difficult to do in Spiral. Who knows, maybe we're also missing proper module imports and exports, maybe package management. Yeah, I think in future language development we should be looking towards things like that. And not the type system features. We needed the features that we have now, we really did need, but it doesn't mean that this will be the way to improve the language going forward. Okay, let's. I guess it did build it. Now let's give it a try. Yes, go to plugin. I kind of like to start it from here because in the publish script I might accidentally publish the language instead by reflex. Okay, not bad. So what's going on here? Okay, do we have any errors than the ones here? Oh yeah. Okay, I'm feeling pretty confident about this. So we'll release a new version of Spiral right here. Global functions can through the annotation in the parser. Yeah, this is great. Yeah, the change only is growing, and that's good. If I had to do all of this from scratch, it would be a ton of work. It won't be a easy job for somebody to come in and try to replicate Spiral from scratch. Okay, let's see. What do we do? Yeah, we need to release it. Okay, I'll close this for now. Go here. And then run this thing. Another. Okay, we'll program in the extension manager for the time being. I'm just wondering, like, would this also work for? No, I mean, the local functions we can just check during type inference. They don't have to be. I mean, they're not they were not restricted. They aren't restricted to being functions like global statements. Local statements aren't restricted to being functions like the global statements are. Okay, and this is model input. Model input. And we need also model output. Okay, great. We have the model input, model output, and the game model. And maybe this should be renamed model game. But yeah, I don't really like the way this is being initialized right here. So maybe it would be better to just create the game model and then initialize it afterwards. Yeah, well, let's do that. Init. Okay. Let's get this. Oh yeah, great. But okay, and I'm not really happy with this. Like, we have the game model. I mean, we have the game model function, and this one takes in the graph. Yeah, I don't want this to be here, even if it is. Let's move it into here, and maybe we'll make it. Maybe we'll name it create. Creates an uninitialized model. Call init on it. Using. And in fact, I wish this could be checked at compile time. I mean, we could use a hash map and then make it mutable afterwards. Okay. I'm thinking about how I want to do this, but for now, okay, let's put in the graph and the model input and the model output. Graph model input model output. Exists model. So this has a meta variable left over in it. Yeah, I guess we need to properly annotate this. From the graph T and I guess this is And damn it, I don't want to annotate all of this, but I have to. We'll just copy paste this. I'll just put it here first, then. Oh wait, it's not only. Yeah, the graph should have an existential. Okay, let's exists the graph. Yeah, nah, but now it's complaining that it needs a regular thing. Inputs mid out, whatever. Let's just name it mid. Input. Yeah, why not like that? Okay, now what exactly is the problem here? It cannot be applied. Yeah, okay, fine. Model mid, model input. Expected symbol as the record key. A model output. And yeah, this kind of brings to my attention. Do we really need an existential here? Just a second. Okay. I think I understand what I want to do. Instead of just having this game model, we're also going to have another nominal, which will be like an uninitialized version of this. If we find a game model in the wild, then it will assume that it has already been initialized. We don't want to call initialized on already existing game models. So that's one thing. But I'm also thinking, and I want to loosen up the parser a little. I mean, it's kind of, since we are working on the parsers already. So we have, for example, we have this trace per warp, and we have to put in this parenthesis here to make it a function. But it would also have been fine had it been a constant. Okay, this one we can. It's an actual expression, so it's not a constant, so it would be restricted. But I would like to be able to write, let's say, this. Right now, global inner statement shall return functions known at compile time. But it will be bad if we relax this restriction just a little. Yeah, I mean, we don't have to do this like so. It's not like the warp size ever changes in GPUs. Oh, so yeah, why not? Let's do another improvement to the parser. Raw. Okay, row pair array B. Okay, loop A, and we actually need a semicolon here instead. Oh, raw record. Oh, what the hell? What's the node for the record? Oh yeah, this is so annoying. Record with symbol, record with symbol modify. Air A B Air A B C. Huh. Oh crap. And we also have to modify the top level statements if we wanted to change this. We have to add the top level constants specifically to the language. Do we want to do that right now? Oh my. Okay, this is kind of a pain in the ass. I don't think it will be like this. Okay, I don't want to bother with this right now. Forget it. Never mind. Let's go back to programming. So what we'll do here is make an uninitialized version of the game. Game. Okay, let's make it game graph and input and output. Graph mid graph. Okay, we have the game graph game model. We can run the game model from model. Yeah, no, not bad. We have the yeah. And what this will change completely. Instead of passing a game model, we'll pass in a game graph here. Graph graph and now we can finally initialize the model. Model equals parameter initialize. No wait, not like that, but how was it done? Model equals create model from the graph, and then we initialize the model, and then we actually return it. No. Let's comment all of this out. And this will be input, output. Game model AB. Oh yeah, this is much nicer. We just create a game graph. Yeah, now that we have this, we can move. And we'll go into the game model. No. This is the Leduc model. And we'll return the model graph. And not a model graph, but a game graph. Game graph. Okay, and this is graph equals graph input equals model input, output equals model output. Boom, boom, boom. And the game graph is in game model M. Okay, ML. Oh, it's so annoying to have to keep writing this. Can we do it better? We have the ML. Let's rename these two models. ML models and models game graph. And why is this a problem? Oh yeah. Let me do this. Open game graph. Okay, and oh yeah, this needs to be in an existential. Exists. Oh, finally, we fucking have this. And Leduc input. I've added a previous clip to the timeline, and I'm really happy with this. And this time I'm doing the timestamps as I go along, so they should be a bit better than for the past videos. I should have put them to render during the night, but I forgot. I started playing Long War and then it was 1 AM and then I completely forgot that I needed to render the YouTube videos. I'll be sure to remember it tonight. So the next video should be posted in like 2 days. But yes, I'm very pleased with this. And you might be wondering why. Because we have the input, the graph, the output, and then we just create this game graph. And this is all that we need to run this game. And okay, we've also renamed these two models. We can create it from model data and then turn it to model data. And this initialize is very important to me, because now the game graph is the uninitialized version of the game model. And once we go from the graph to the model, we know that the model is initialized. And that's how it's going to be done from here on out. I very much like this. So let's go into the play. And we have the, okay, let's do this game graph. What did I do? Game graph, and then ML models. Oh, fuck. This keyboard. I mean, it's not the keyboard's fault, but my own. You know, you kind of get used to a new keyboard very quickly, but you still retain all the habits that are hard to break. I think I'll be getting used to this keyboard for the next decade. I think I should be able to type fast now, but meh. Okay. Oh, so this is the model data. ML models init. ML models to model data. Oh yeah, great. Yeah, I like this. This is perfect. I like how this looks like right now. Instead of typing something like game model M, I mean, it kind of really irks me to put that M at the end. Maybe instead of having the core libraries be named like this, you know, Sam, Dam, Sa, Listem, maybe they should be named S, Sa, Lists, or Sas, or okay, forget what I was talking about, but this is much better as models than game model M. Okay, so what's going on here? Okay, we have the game. We have the model data. Now we want to run this. We just need to take this model data and turn it into an actual model. So yeah, just a second. Let's go into the models, and from model data, and we have this fucking thing. Instead, game graph input and output. Game graph. Oh yeah, input and output. Yeah, not bad. And what's this? Graph model data model. Okay. We need to extract the graph from the existential. Okay, graph equals existing graph. Oh, nice. Okay. I like this. ML layers, model data. And we'll just take this model gain graph and use the also pass it the model data, and then we'll put it together. And we'll put it together here. Okay, first let's make the model. Model, and that's model gain graph and ML models from model data. And we also need the state eternal. Okay, we have the model data here. State private model data. Oh no, it's not private. It should be in state internal. Oh yeah. Okay. You can see the model data like here. The highlighted section, so we can be sure it's there. I mean, we knew that already because it's written out clearly here. So okay, ML, we need now what's the oh yeah, the state is here, and the state model data. Okay, so we have the game model. Oh nice, and we just have to run it, I think. And there's also the question of what the input should be. Okay, here we have the messages, but we don't have the history. Okay, we have the game model. We have the game model. Where is the history? Okay, never mind that. Let's just run the model. I mean, not really run it, but we'll put in a placeholder for the data. Oh, fuck's sake, where is it? Fail me to do. And ML models run. How do we run this? We put in the game model. Game model and then the input. And then we get out the action and the sampling probability and sampling probability selected. But for now we just want the action. Okay, model data. Okay. So we can use this as a template. Okay, action. Actually, I don't like this. Sampling probability selected. this is just a reminder for later. And we don't need to do anything else. Let's just copy paste this. Yeah, this is nice. Now, the only thing we are missing is the data, and then we'll be able to run neural models on the Leduc game. So, where is that history thing? Essay list. I mean, is it coming from the game? From which module is it coming from? Okay, Leduc, and here it has the game module. And yeah, here it has a bunch of things. Choice action card. And let's take a look at the messages. We do have a list of messages, and okay, here it is selecting a card. Here it's also getting a card. We can see the player actions here, and the showdown will never be passed into this. Okay, not bad. And the messages are a resizable array. Like is it only of size 10, or can it be even larger? Okay, let us think. First it gets dealt one hidden card, then the longest sequence could be check, raise, call. That's 4 actions. And then it could also get another card, then 4 actions. So like 2 cards and 4 actions. In total, at most it can get 10 cards and actions. Okay, yeah, this checks out. So what we have to do is not really map it, but choose all the stuff from here and put it into. Yeah, we need to filter out the messages and then map them over. And the combinator function that's used for that is choose, at least in F#. I'm not sure we even have it in the essay list module. Okay, so that's what we need. We have the messages. Where are the messages? Yeah, here we have the messages, and this is a resizable array of size 32. I mean, static array list of size 32. And okay, let's calculate the static array list module. We have the push and the pop. And I don't think we have the choose combinator. Let's take a look at the in array M. Oh, we do. But unfortunately, we won't be able to use this on static arrays. I know, whatever, we'll just do one from scratch, who cares? It's not like this is difficult to implement. It's just a loop. Okay, so we have the push and the pop. Then we'll choose for all demand A and B sales. And what I will do is create a new static array. Now, how is that being done? As I create, really? Does it have a create here? Oh yeah, but this one needs an integer to be passed into it. Okay, so we have this as I create, whatever. Out as I create. Oh yeah, this works. And now what I have to do is iterate over the essay list. Array m iter fun x. We also need some kind of function. Match fx with some x. If it's some, then we just push it. Push. Oh yeah, out x. Otherwise, just skip over it. And oh yeah, we need to iterate over the input array. Yeah, okay, this is very nice. And we have the choose combinator, and we can use that to filter static array lists. Let's just give it a try. And we can also put that into the dynamic static array list, but never mind. I mean, it's not never mind. Let's just do it. Let's just do it. It's very similar. We can also simplify this. Option m iter push out. Yeah, and we can also write it like this. Yeah, this is much better. Now you know how functional language, how the process is done of writing things in point-free style. You cannot write it verbose the first time around, then you simplify it. Or rather, you don't really, it's not like you explicitly want to simplify something. We're writing it out like this because it's easier to think about, it's easier to read, it's easier to understand. You simply notice a pattern and then you act upon it. Now imagine if you were programming this in C, you would forever remain at a low level. Using a language like something like C, which has low of abstraction ceiling, actually would prevent you from getting better as a programmer. And Spiral wouldn't. Spiral would only make you stronger. So you should program in Spiral, and maybe send me an email about what you're doing, because there are not many users of it right now, and I'm curious about, if somebody is using it for something, I'd like to know. I mean, nobody talks to me. I'm mostly making these videos for an invisible audience, and that's a very lonely existence. Let's move on. Um, mm, mm. Uh, okay, we're in play. And okay, let's go. Let's do essay list choose, and we'll have to do the conversion function here. I mean, we don't have anything, and I mean, we don't have anywhere better to put it. And how do we get to the messages? Messages. Post message refm to local. Okay. This will extract the local reference. I mean, it's really complicated having to deal with C++ references. Wait, we have a parsing error. Anyway, as I was saying, it's really complicated to deal with C++ references. Okay, so what kind of types do we have? Okay, first let me just finish what I was saying. The reason why it's complicated to deal with C++ references is because they have very quirky types. So here I'm actually converting them to a value type in Spiral, even though it will remain as a reference type in C++. Honestly, I'm not sure whether this is. I mean, it's kind of risky in terms of programming safety. It could result in bugs, but I still choose to do it like this. Okay, so we'll iterate over the messages. And which messages are there? Leduc game, and we have player got card, int card, okay. Player got card, ID, whoops, card. Okay, some card. Choice one of two. Maybe this should be choice 2 of 2. What the hell am I getting an error? Okay, this choice type is, I think, in here. C1 of 2, C2 of 2. Oh yeah, I guess this needs to be lowercase. Okay, perfect. But we also have to check if the current player ID is equal to this ID, because these cards are hidden. I mean, we shouldn't be passing the card for the opponents for the opponent into the game model. Because in that case it will know what the opponent card is, and they will be able to play perfectly. Okay, I see list 6i32. Okay, let me think. I mean, what am I even thinking about? Yeah, where is the player ID? UI game state, maybe? What the hell is the UI game state? Okay, where the hell is the public state? Oh, for fuck's sake! How do I get the current player ID? Oh yeah, and this is crazy. I cannot figure that out at all. Like here we go the game, and where is the game ID? Where is the table? It should be in the table. It's okay. So in that case, we have to take a look in the game node to figure out whose player turn is it. Okay, let me pause for a bit. Okay, we have the table right here, and we have the player turn here, and this is the current player. I mean, I think like, could it also be the previous player? That's a wait, no. If it's a human, then yeah, if it will be waiting for the action. Yeah, okay, so yeah, that's the current player ID. Okay, I get it. Not a player turn, but oh yeah, it is player turn. Yeah, it's indexing into the player type here. That's why I'm getting confused. But this is an integer. Okay. If okay, when ID equals table player turn. Okay, yeah, that's good. Now which nodes are there? I mean, which nodes are also there? Community card is okay. That one should be simpler. Sum C2 of 2 card player action ID action. The players can see all the actions. None of the actions are hidden, so we don't need to check the IDs here. Sum C2 of 2. Actually, this is C1 of 2 action. And the last one is showdown. And I don't think we'll be covering that one. Winner ID, chips 1, cards shown. Oh yeah, that will be... this node will be ignored. So we'll be ignoring all of these. None. Yeah, now we have the data for the model. Isn't that great? And with this, we should at least be able to run the game with a random model. Let's just, before we do that, let's just make sure that there aren't any... Oh yeah, we renamed these two models. ML models. Oh yeah, perfect. Let's also get rid of the bookmarks. There's one here, one here. We don't need those anymore. And now it's time to test out the random player. And once we actually train the model, it won't be random anymore. Of course, it will be a lot more complicated to do the CPR version of this, but we'll handle that when we get to it. Even though it's on the GPU, maybe it won't be a bad idea to... I mean... Yeah, we need the neural network at the very least so it acts as a hashing function. Maybe we'll do these two avenues of research in parallel. On one hand, we do want to train the neural model itself using evolution, but on the other hand, we have to do a tabular reinforcement learning scheme. So simply for efficiency, but for that we can also leave the model as random, at least at the beginning, and at the very end we can just merge evolutionary training and counterfactual regret training. Let me just put this clip on the timeline. Oh yeah, let's finally do some testing. Okay, do we need to compile? Do we need to do anything here? I mean, okay, let's leave this aside and let's check out the namespaces. I'm just wondering whether we need to compile something or like in the train, or whether it will work out of the box. Okay, where the fuck is it? Backend, namespace, Leduc train. Oh, okay, it's not doing anything here. Great. It's all commented out because we haven't gotten to the actual training yet. Over here, everything is fine here. Okay, let's try building it. We have some errors, of course. How can I deem non-existential into a runtime variable? Oh crap. Okay, so that's... It's happening in the real nominal case. So I guess for some reason it's dealing it instead of simply converting it to a type. I guess some of the latest changes did introduce bugs. Okay, this should be easy to fix, assuming the error is what I think it is. Of course, the problem isn't this, but we have to look at the type raw the term. Fuck. Okay, we have the term evaluator here, and we have this T for all, T better if... Why isn't the syntax highlighting working here properly here? I guess the F# language server crashed. But that doesn't matter. What matters is where is the term level here? TB, T pair, T fun, T union, T type case, T symbol, T apply. Oh, T term. Yeah. Okay, great. It's on line 768. Let's put a bookmark here. And let's reset the IDE. Because something is wrong with the language server. Oh my god, it's still not working. This is crazy. I wanted to show me the type of this, but oh wait, what the hell is going on? Did I accidentally make some kind of change? Oh, whoops. So that's why it's not working. Okay, and okay. It wasn't the fault of F sharp, but it was the fault of my keyboard, my light finger. Okay, so this evaluates the term scope. Okay, that's reasonable. But yeah, that would also end up dimming the final expression. Previously this was reasonable, but now it's not. Turn scope. Okay, we'll just have to inline everything here. Let's just copy this. I mean, oh fuck. I want to press escape and something completely different happens. Okay, now let's put this here as a reference. And then now we want to evaluate this term sx. Okay, term sa. And there's nothing wrong with that. Sorry, I'm just fiddling with the keyboard. And in case of the S, we also need to modify the environment. Let S and this will just be dictionary hash identity structural. And yeah, it would be a good idea to factor this out. And what we will do is data to time. Okay. SA and oh yeah, it also needs the environment. And I suppose that's it. But it's kind of dangerous doing it like this. So let's copy paste this, and okay, I'll just put that here just in case. We are going to undo all of this. Term scope, term scope, and term okay, term real nominal. We're going to put this here. So in the future, if I need to change one of these four, I mean, if I need to change this one, maybe I'll extend the partial budget or with something, and that way I'll immediately know that I also need to modify this. Okay, now let's go here, and we'll just do term real nominal. And yes, this is fine. Is any function even using this? Oh, it is. I guess there's a reason for everything. A bunch of places are using this. I'm pressing escape and it's not exiting, but never mind. If we find all references for this, yeah. A few functions also use this. Yeah, I guess it's fine to put it like this. So let's oh yeah, I need to exit this, I think. Okay, I already did. Okay, fine. That's that. Let's give it a try. Who's there now? Unsupported type encountered during serialization. Interesting. It's telling me to check out the terminal. Array base. So it's a pointer. I mean, so it's in serializer. Okay, let's check this out. Is this doing serialization or deserialization? That's what I'm wondering about. What the hell am I looking at the tests? It's in utils. This is line 64. 64. Okay, and this is calculating the offsets. Okay, I see. Oh damn. I mean, but isn't this serializer? I mean, what's the serializer even used for? Is it for putting stuff on the GPU or no? I mean, when we're moving things from the backend to Spiral, we're using the JSON serializer. This one is for putting stuff on the GPU and back, and it shouldn't be. Yeah, it shouldn't be serializing the model data. I mean, the model data. Okay, where is it? Where is it? Okay, we're going to play. This is the part of the internal state. I mean, because it's a part of the internal state, I mean, it's also part of the private state, the model data. So I guess it needs to move it back and forth between the GPU and the host. Okay, how will we do this? How will we do this? I mean, on the GPU, this will be raw pointers, and on the host, this will be these will be NumPy arrays. It's very easy to pass NumPy arrays into the GPU kernel. You just pass them as they are, and then they get auto-converted into pointers. But what about the other way around? Okay, let me pause about it so I can think about this. Okay, for now, let's just release another version of Spiral. Fixed an error in at least I think that's the version. Okay, let's. I mean, no, not here, but let's close this. Let's publish this. Okay, now let me pause for real. Let's resume. You know, I wanted to brag today about how I'm feeling refreshed even though I went to bed at 1 a.m., but I guess that wasn't true because I really fell asleep. I guess I'm more tired than I thought. I mean, unlike the usual, unlike usually when I go to bed late, I slept quite well tonight, but I guess I didn't get enough rest, and that's unfortunate. Anyway, we released the new version of Spiral. This one should evaluate the real nominals correctly. Kind of wondering. Yeah, but whatever. I was just wondering whether there is a change log in here somewhere, but that doesn't matter. What are the features? Runtime status, not activate programming languages. Settings. I didn't even know that extensions have these. Okay, never mind. Let's open this. And we're going to think about the private and public state a bit more. This state, even though it's part of the private state, it's not necessarily a part of the game. So I don't think we even want to be passing it through the private state, unlike here. Instead of that, yeah, but we do need to initialize it somehow. We wanted to go one way, but okay. I guess okay. Let's make it state neural and be done with it. We'll have the third kind of state. Model date. Okay, graph models in it. To model data. Okay, this is fine. Whatever. And we have the state internal. I guess this could have the model data. It's fine. And I'm surprised that we don't have any errors here. Okay, let's think. We have the state. State. And yeah, we don't want to deserialize everything. We want public and private, but not neural. Public, private, neural. And this is how we can the public and the private state are being passed to the GPU and back. We are serializing them to the to the serializer. I mean, what's even this? I mean, we're serializing them to the GPU using this serializer thing, which I conveniently forgot what exactly was right now, but it's responsible for serializing stuff to the GPU. I'm guessing it creates an array, and then we can use the serialize function to put stuff on the GPU. We also have the serialize function. And this series state has only private and public, but not the neural. Yeah, not bad. Instead, the neural is being passed through a separate channel. Oh yeah, okay. It's going one way only. It only has an array and the size for that array, and that's what it is passing through the language join point, through the backend join point. So I guess this should work. Okay, let's try building it. Oh, did it really build? I guess it did. Ah, fuck. Sorry about swearing so much today. I'm cursing like a sailor. Unsigned. Oh yeah, we set this to 255 instead of -1. Okay, never mind that. Oh, okay, and I guess we can try running this. Let's press Ctrl-Shift-B and we'll see where that gets us. I mean, do we even have the option of selecting the computer player? Okay, this is train. I think this is... Okay, I guess it's doing nothing right now. And I hope it's not... Yeah, it's not showing any message. Never mind that. Let's go into Leduc. We have the computer, human, and we don't have the random player, unfortunately. Okay, let's also put the random player. Let's go into the front end. I don't want to try running this and then ruining my mood. I want to see that the random player still works. UI, front end, Leduc. Computer, human. Random. Oh, this is an array. If we set this one to random, what will happen? Let's go into the browser, restart, select Leduc. It did nothing, absolutely nothing. I mean, shouldn't it have updated all this? Computer. Oh fuck, so it's not generating these automatically. It's getting them from the player type. Okay, but never mind that. What's this thing here? Let's look for all the references. Find all references. Const players. Beyond type players. Oh, so that's in the default player type. Okay, I see. Player type. Okay, okay. Okay, so why is this like so? Computer, human. I mean, what's the problem? Oh yeah, I think what the problem is that I was going to say that the problem is that the editor is keeping the old information around, and we're getting the wrong thing here because the lit plugin can be slow to react. Let's try running this again. Great. As you can see, there are no more errors here. It frequently confuses me why these kinds of errors frequently confuse me in the past. Okay, so we have to run the server again. How annoying. Okay, and we also have to, yeah, put computer. Okay, let's make it a random, whatever. We'll put it here. Even though we really should be generating this automatically. And in case you're wondering how that could be done, let me show you. Const possible player types. Computer, human, random. You know, maybe in TypeScript we could go from values to types. TypeScript. Type of something like this. Runtime type checking and type queries. Type queries, type for a variable or a property. Oh yes, okay, perfect. Okay, let's do. And hopefully it infers this as a type literal. Type of possible player types. String or never. Yeah, fuck. Type of possible player types. Yeah, can we map over all the stuff? Return type, type of get user. Oh damn. Yeah. It's too complicated to actually extract the actual types. So I guess we have to just type them in. Whatever. Two possible player types. One. What is it complaining right now? Player, sorry. Okay. It's like this. Oh, now let's go into the computer. And what we'll do here is possible player types map x HTML and what are we going to do here? Like, we can just, I guess we could just put in the string here, like x0, x is players, and this should be a string, I think, computer humor or random. Okay, like this, and then we also do it here. Now we don't have to copy paste it constantly in different places. Okay. Well, let's see whether this works. I mean, you should have updated it automatically. 0, 0, 0. What the hell? And it's detecting errors in the compilation of this. Oh, this is a warning. Identifier CP is undefined. And I guess we're using CP random in CUDA code for some reason. And that's the... or maybe not. Okay, let's take a look. I mean, but this should be... This is on line 5388. Yeah, and it's trying to do this in CUDA code for some reason. How did that happen? Okay, never mind that for now. What we want to do is first figure out the front end, then we'll deal with the back end. Like, okay. Oh, I put in 0 somehow here instead of x. Oh, how did that happen? Okay, great. Now let's figure out what the hell is going on here. Identifier CP is undefined. I mean, I guess it's trying to initialize the model. CP random normal. Okay, so you should be initializing it. Here's the init. Okay, ML models init. Let's think about that. ML models init. It's creating the model, so maybe from model data to model. Okay. I want to check this out. Maybe it has something to do with this. ML models. I mean, no, it shouldn't be initializing it here. Oh, damn it. Why is this happening here? Yeah, it's also happening here. I guess it's happening in two different places. Oh, don't tell me. Like, I just got an idea that it was somehow evaluating this on the GPU because of the backend switch, but no, I don't think that that's really the case. It's not like the code generator just puts everything in the dictionary into the backend. It only actually generates the code that is reachable, and not the one that is reachable in the type inferencer. So CP random normal. I mean, this is really weird. Okay, let's try having this do nothing. I suppose we build this. What exactly would happen? Oh yeah, now it's not happening on the Python side, but it's happening on the CUDA side. Oh, that's really weird. So is this maybe happening in the event loop? Okay, suppose we, as a sanity check, let's try commenting all of this out. Yeah, the kernels are empty. It's not generating anything. So, okay, suppose we try doing this. We build this and CP random. It's not happening. I meant to just select this. So I think it has to be in the event loop. CP, yeah, it's in the event loop. Oh, it's in start game. Oh, okay, I see. It's in start game. And then it runs the play loop. damn. So this init also ends up initializing the neural network model. I didn't think about this. Oh damn it, just where the hell are we supposed to... I didn't mean for the init to also initialize the neural network model. It should only be initializing the game state. Okay, let's make a init game. I don't like this. Are we sure that instead of adding it to the internal state, the neural network model could be separate from it completely? That's what I want. But never mind it for now. Let's just get it to build. No. These errors are happening because yeah, it's setting the internal state, but it's initting everything. Oh, damn. Okay, so I guess we should only have public and private state, and the neural state should be separate from all this. Okay, how are we going to... Okay, let's make it init neural state neural Okay, so we now split the state again. We'll no longer be passing we'll no longer be passing this here. Okay, where's the internal state? Yeah, okay, MLR small data. No, where the hell is it? Neural Do we have any type errors here? Okay, I don't see anything. Okay, and yeah, we need init. We have init and we have init neural. I guess. Okay, now we have to think about what we want to do with the state itself. We have the game state. We can also have the. Do we also put in like a third tuple, which will be the neural state? Let me pause. Okay, let's do the simplest thing possible. There's no need to think so much about this. Even though I have to take a break to think about it. Okay, where's the... here's the state. We'll rename this to state game. State what? State... I mean, okay, this will be the new state. And the game, state... Game... Neural, state neural. Okay. And this one will have to nest this. And okay, this is game. Game equals this, and neural equals state neural. Yeah, it equals model data. And basically this thing. Okay, now we need the state game. Set eternal state game. Okay. Finally. We have the play loop. Do we have any other loop? This takes in state internal, takes in a message. State neural. Okay, I have to leave right now for lunch and then to take a swim. We'll finish this later. Let's resume from where we left off yesterday. My plan to actually leave the rendering to be done overnight isn't working. I keep forgetting about it. So what I'm going to do is just render it one video per day after 6 p.m. and then that will take care of it. So okay, let's see. What we have to do is weave this set neural through everything that we need. So let's see, we have the init. Where's the init? This is the init. Okay, let's do init game. that takes care of that. And I guess we need to pass in the state neural, I think. State neural. Perfect. Let's just do it like this. Game. Event loop. Oh yeah. We shouldn't be passing neural through the internal state, but I thought it would be like this, but no. I said, yeah, we need to pass it here. Oh, perfect. Do we still have a type error somewhere? I guess we don't. What's this red thing? Oh yeah. Okay. I guess we're all set. Ctrl Shift B. Now let's start the game. Oh yeah. We no longer have the public and the private thing. Okay, let's take a look at the backend. Namespace, Leduc game. Game public. Yeah, like this. Now we'll have to try it again. What the hell? Print state. Fuck. I'm printing the state, but it's telling me it's a none. Oh yeah. I think I forgot to actually build it. Spiral build file. Okay, let's try this again. Oh, perfect. Something's happening. It's going to run the kernel. Device side assert triggered, and that shouldn't be happening because the shared memory used in the matrix multiplication node is lower than the allocated amount. Really? Oh, how the hell? I guess we'll think about this. I didn't expect there to be a problem in shared memory. Oh, what the fuck? Okay, this is in the matrix multiply, and I'm very happy that I actually took the time to put this thing into the language, this assert. Otherwise, we would never have caught this. I wonder. It's in base, yeah. We specifically put this in for exactly this reason. So okay, I mean, let's go into the matrix multiply again. I'm just curious, what okay, core ext, maybe I don't even need that, but console, right, ln, core ext, offset, and equals okay, let's build this again. I'm just curious what will come out. Well, we also need to restart all this. I mean, maybe we forgot. Maybe we simply forgot a case in calculating the dynamic shared memory, so it's not doing it properly. I guess we'll be seeing 0 as the shared memory used. But you know, I'm confused why it's even trying to run the. Oh, I guess it's because. Yeah, the first player is set to computer. So okay, let's see what comes out here. Offset end 1536, and the shared memory used is 0. Yeah, I guess this is roughly what I expected. Oh, the compilation times sure are long for the Leduc game now. They're like 25 seconds. And it's longer than the No Limit Holden game. It seems the longer we work on this, the longer the compilation times get. There's no way around it. Okay, so let's go into the layers and pass calculate dynamic shared memory. Look, matmu. Right, input key is car, key tensor pair. Okay, I get it. Set offset, maximum size, get offset. Really? Oh yeah, yeah, it does need to be set to the maximum, or it should. Okay, so that's weird. Okay, let's print a static memory, and if we, well, we need to build that here. So it's kind of weird. I mean, if it really is wrong here, then it should also be wrong on the tests that we've been doing in the previous. What the hell? Okay, we're building this, but nothing is getting printed. So, I mean, oh. I mean, it seems like this function isn't even getting started anywhere. Oh, that's very weird. I mean, okay. I mean, it should be started in the init, I think. JSON serialize init. Print. Okay, this is finally getting printed. So we have the model game graph and we have the ML models in it. Okay, model game graph. When should this be in model game graph? Okay, let's take a look at the ML models in it. I need to understand this. ML models and init. Okay, this initializes the parameters. Ah yeah, but come to think of it, I just realized something. Like, this is where... In this run, this is where we are supposed to be actually calculating the offsets. I mean, the shared memory sizes. Instead of using this run, which allocates it as a 0, it has a memory parameter, I think, it has, yeah, shared mem. And this determines the shared memory size, and we are not using this anywhere. Down. Okay, so I guess it's whether Giga. Hold on, game graph and then pass calculate dimension memory and this should be ML layers, I think. let's change this a bit. You know, this man. Okay, so then let's get the actual graph. Graph equals exists the graph, and then pass dimensional memory graph. King graph AB. What the hell? Oh yeah, fuck. I mean, we should have done this. I don't think we need this anymore. Like, do we even need this annotation? Oh yeah, and this now actually passes type checking. Returns the amount. I'm kind of wondering. Okay, where's the model type? Yeah, this is how it was. Okay, right. ML models. Now this is returning it as U64. Wait, is it returning it as U64 or? Yeah, we want to return it as the default integer. So I'll just convert it and be done with it. Perfect. Oh, now we should be passing the exact amount of shared memory being used. Spiral build file. And we can try running this again. We have print static somewhere. Print not here. Where exactly? Yeah, here. I'll build it again, and then we'll close a lot of these. We'll run them again. We have to. What the fuck? Key error game. Oh yeah, it's not serializing the neural state. Game equals now let's close these two and run them again. It's kind of annoying to have to do this, but that's an issue of doing a UI in Python. We have to run the front end and the back end separately. Oh, it actually worked. Nice. Let's try playing this for a bit. Raise. Well, call, and the game is a tie. Perfect. And this is actually running on the GPU. Okay, let's prove that it's running on the GPU. We'll go into here and do. Okay, let's open core extended. Open core ext so we can get the console. Right. Running the GPU model. The action is I'm guessing it recompiled the library, and I mean the backend should automatically react to recompilation. That's what I meant to say. Oh, now it's running the kernel. Running the GPU model, and the action is raise. And in fact, it did raise. I'll raise it again. And we should see, yeah, call. And the GPU model, the action is call. Yeah, and this call is basically a check. Raises. I of course am going to call, and within 13 chips. Yeah, this is perfect. And what we just did is implement a random neural player. We've been trying to do this for like how long, and we finally did it. It's amazing. Okay, so this is a good time to stop and think what we are going to do next. Like, we have a random neural player in Leduc. Do you want to move on to training, or do you want to maybe implement the same thing for no limit hold'em? Who knows? Maybe it won't be a bad idea instead of moving on to training to do the same thing for no limit hold'em. That way, we'll with prepared field for the future. We'll see. Okay, let me have breakfast here, and we'll figure that out when we get back. See you soon.